long time, and I've been doing security for a really long time. So I've used JWTs in code that I've written. I've tested apps that have JWTs in them, and I know that when I first got started, or even a little while into testing and developing, I still wasn't super comfortable. I didn't know I knew how to implement them, but didn't really know about all the vulnerabilities that could exist within them. And just over months and years, and particularly lately, I just been writing a lot of code around them for the purpose of really exploiting them in different ways that you might think, right? I think a lot of us probably are aware of the different cryptography issues with JWT, but the thing that I really like to do, and I do it in my training, I do it in my talks, is put myself in the mind of the developer and not so much look at what's wrong with the specification, but look at what are some bad decisions a developer could make about when to use these things. And so I've just been exploring that and figured, you know what, I'll throw a talk together that just shares some of what I've been learning. And so that's what we got going on here today. This is a little bit about me, but what's way more important than who I am is why I do what I do, okay? So it's my personal belief that God gave me certain abilities, right, to do the things that I do, and Jesus gives me the strength to do those things. And so if you get anything out of this talk here today, I just want to let you know that I won't accept any glory or thanks or anything for that. It all comes from Him in my book, and I am just happy to have this opportunity to serve Him in that way. Okay? So all that being said, the stuff that's on here, for me, feel free to digest it, way less important than the stuff that I want to talk about and deliver to you. So let's go ahead and just skip this and go right into what we're going to talk about today. So a couple of things, we'll talk about what they are. So if you've never even heard of JWTs or JWTs, as they are called in some cases, I'll briefly go over what they are and kind of how they're composed. We'll talk about why they matter. Then we'll talk about how they're used, and then I'll jump into 3 different high-level use cases: authentication, authorization, and information exchange. We'll dive into some specific use cases within those to explore them a little bit and do some demos. Then I'll conclude and share some stuff with you in terms of resources and credits and attributions for some other stuff that you'll see in the presentation. So what are JWTs, and what are these things called claims that are within JWTs? Well, JWTs are defined by RFC 7519. And if you ever need some sleep, if you're ever short on sleep, or you want to know a little bit more about JWTs, go read an RFC, or specifically this one, because you're guaranteed to get one of those 2 things if you do that. You're going to get some sleep, or you're going to learn a little bit about JWTs. Okay? So by all means, that's the one that it comes from. If you want to really deep dive into it, that's where you go. And it defines a JWT as a compact, URL-safe means of representing these things called claims to be communicated or transferred between 2 parties. Now, the significant piece of that I want to mention at the moment is URL safe. It makes them really good for using within web applications that are over HTTP and communicate through URLs and things like that. So they're ideal for use over the HTTP protocol, and they just basically transfer these things called claims. Well, what is a claim? A claim is a piece of information that asserts something about a subject represented in a name-value pair. So if you've ever dealt with arrays or named arrays or things like that in JavaScript or any other language, you're used to seeing name-value pairs. And you can see an example here at the bottom, right? These are 3 different claims. You have a name, colon, and a pair. And when you put one or more of these things together in a JavaScript object, which is where the JavaScript object notation in JSON Web Token comes from, you get what's called a JWT claim set. And here you see a set of claims. Now, there are a couple different types of claims: registered, public, and private. I won't go into the details of those. Feel free to go check the spec out if you want more details on what that means. But ultimately, none of them are mandatory. All of them are option, and it's very loose in how these things can be used. Okay? There's nothing technically preventing the developer from completely branching from the specification and ignoring the fact that some are registered, public, or private. The spec just has some definitions for that. So why are these things called claims? Because on the previous slide, they look just like JavaScript object attributes or properties, right? So what is this word claim, and what does it mean? Because that's important to how these things are used. And basically, you've got a couple different parts of a relationship here in which these JWTs gets passed between. You have an issuer, is somebody that creates a JWT. You have an audience, someone that actually processes the JWT. And within the JWT is information or these claims or assertions about a subject. Okay, it's not even necessarily like the person that has this thing, but there is a subject that the JWT is associated with. And the things that the issuer is telling the audience are called claims because this thing typically transfers through an intermediary. And this intermediary may not be trusted. If you look at this diagram right here, you have a JWT that perhaps is coming from the authentication server, which is the issuer, and going to be processed by the resource server, but it's being communicated by this client. So this client is an untrusted entity, right? Because this is, it could be a bad guy sitting there, not necessarily an honest user. And so they're passing this JWT that's making a claim about something that they learned from the issuer. And until there's some sort of evidence that's making this claim truth, it's called a claim. And so that's where we kind of get that. Just like we would say, use the word claim in the English language, that's how it is here as well. It's something making a claim about it, and until there's some sort of proof, it is just that, a claim. Okay, so claims should not be trusted unless certain things are verified about it, and then it can become truth. And those two things are, number one, do they come from a trusted issuer, a trusted origin? Are they actually being provided by something that the person receiving it, the audience, deems as trustworthy? And can we verify that it's not been changed in the process? Okay, so integrity is very, very important when we're talking about JSON Web Tokens. And integrity is one of those words that's a part of that CIA triad in security. And what is like the main way that we ensure integrity within the CIA triad? Within security. Some sort of signature hashing, something like that, okay? And so we use signatures, or JWTs use signatures to actually enforce integrity within these things. And so whenever you see a JSON Web Token with a signature on it, it's actually not called a JSON Web Token, or it is still a JSON Web Token, but it's JSON Web Token in what's called the JSON Web Signature structure. So there's a couple different structures, and JSON Web Signatures are one of them. The vast majority of the JSON Web Tokens we see are using this structure right here. And as you can see at the bottom, there's a couple different parts, right? There's a header that actually describes the cryptography part of this. How is this thing being signed, and what are all the different variables with that? Then there's the actual payload, which is just the claim set that's going to be in there. And then there's going to be the signature that tries to that the receiver or the audience can use to validate the integrity of that claim set. Okay, so there's three different pieces there, but the centerpiece is what's really, really important there, the claim set. Because that's what the JSON web signature structure looks like. Well, sometimes integrity isn't enough, okay? These JSON Web Tokens, if you've dealt with them, but you know this, they're transparent by default. You can see inside of them. You can decode them on JWT.io or using Burp Suite Pro, and many different, Base 64 decode them, and you can see them. They're transparent. The data in them can be seen, and that's not always desirable. So there's another structure built into this spec, which is called JWE, or JSON Web Encryption. And it's fairly similar, okay? You've still got this ciphertext payload right here in yellow, and that's basically what's going to be the JWS that's then been encrypted using all these other variables, and then all these other pieces to it basically tell the audience how to decrypt it in order to get back at the JWS, which then gets validated with its signature, and so on and so forth. So you've got this technology that ensures both integrity and confidentiality. And so it's a good way to communicate data over HTTP because it's also URL safe. And so why do these things matter? Well, because they're a core component of modern web applications design because of all those things that I just shared. Okay, the problem with it, though, is that the spec is really, really poorly designed from a security perspective. When the spec was released in 2015, immediately we saw this none algorithm attack coming through. Okay, and if I get some time later, I'll show you how the spec breaks this down and how this thing was even introduced. But it's literally in the text of the spec that you can just tell the audience to not check the signature, and oh, it's not going to do it, and I can just bypass it. So it's in the spec that this is how it works, and that just was the start of it. So here we are 8 years later. There's been tons of vulnerabilities that have come out against JWT that are in reference to how the spec handles cryptography. And in Black Hat, 2 months ago, there was 3 more vulnerabilities that were disclosed. So the spec is just broken pretty badly with regards to cryptography. Okay, well, if it's so bad, then why don't we have an alternative? Okay, well, there are alternatives out there. You see a couple of them listed here. There's macaroons, there's pesetos, right? But the reason why we don't use alternatives is because they don't have a specification. JWT has a specification, an IETS specification, and from a political perspective, that makes it the standard. Okay, that makes it the standard. And what doesn't help is when you had other organizations go and start developing authentication protocols and authorization protocols, they actually built JWT, the specification, into their specifications. And so now, if you're required to use JWTs to process ID tokens in OIDC, which we're going to talk about here in just a minute, well, you're already using JWTs somewhere in your application, so why would you then go use an alternative at another place of the same application? So it's just kind of forced adoption at this point in time. So the reality is these things are here to stay, so developers need to be able to implement them securely, and the testers need to be able to evaluate the security of those implementations. Okay, so that's why they matter and why you should pay attention. Now, what are the use cases for JWTs? There's 3 high-level use cases that we're going to explore: authentication, authorization, information exchange. And the approach for this talk is that we're not going to be able to cover, or we are going to cover all the categories, but we're not going to be able to cover all of the use cases. There's just not enough time. So I've just broken out a couple of my favorite use cases that we'll explore. I'm not dropping any 0 days in here. If you go out on the public domain, you can find some information about these, okay? But the majority of what you're going to find on the public domain is going to be about the crypto stuff, the none algorithms, the RSA algorithm confusion attacks, those types of things. In fact, Port Swigger's web security right there, they cover a lot of those crypto level attacks on this. I want to focus on things that aren't covered by things like the Web Security Academy. The ways I see developers implementing them that's just broken by how they've implemented them, not so much by someone leveraging the specs. So we're going to focus in some non-crypto related areas, plus they're just more fun that way, I think. At least the demos are. The examples that we're going to use are based on mistakes I've made as a developer and also mistakes others have made as a developer that I have found through security testing. Because I do development, I also do security testing, and I also do training on how to do this stuff. So as I write code, I make mistakes too. We're all subject to that. None of us are perfect, okay? At least I'm not. And then we're going to demo specific use cases, but I want you to know this. When we demo a specific use case, like when we're going to do a specific attack against an authentication system, I want you to know that that technique that we're using is not unique to that implementation. Right, the techniques that we're going to employ through the various demos that we do are valid against any JWT used in any system. So I want you to remember that and not get hung up on the fact that we did this one thing with an access token and then we did this other thing with an ID token. Those same attacks are valid on all the different types of tokens that we're going to look at, all right, all the different specific use cases, but we just don't have time to demonstrate them in all cases. So just keep that in mind as you go through. So let's start with JWTs and authentication. Now, the majority of the time when you see JWTs used in authentication, you're going to see them referred to as an ID token. And the reason being is because an ID token by the OpenID Connect specification, or OIDC as the acronym, is an ID token. And the specification says it has to be a JWT. So that when you see an ID token, that's typically going to be where you're seeing it as a part of an OIDC flow. Okay? And it's going to be an artifact that proves that the user's been authenticated. So the last thing that happens in an OID Connect kind of handshake between you and this third party is going to be this thing called an ID token. And that gets passed potentially to the server, and that tells the server, this is the person that just clicked the log me on with Google button. And that's what the server processes to log that person in. And what you see right here, this is literally some information taken out of a Google OpenID Connect ID token. So those are the types of information that you should generally see depending on how that token is scoped. Now, the issue that I've seen here in testing and as a developer mistakes that I have made here is that there's a couple of different OpenID Connect flows. Anybody here ever implemented an OpenID Connect client or server? It's a complex handshake, right? It's built on top of something called OAuth, which we'll talk a little bit about in a minute. It's not simple. And when you go reading through the documentation of these various providers, whether it be Facebook, Google, or whatever, there's 2 different flows that you'll come across. There's something called a server flow, and there's something called an implicit flow. And they have very different security implications. And it's very easy to be implementing, say, the implicit flow, but reading the documentation from the server flow, and bad mistakes can happen. I know because I actually did this, all right? I was implementing an implicit flow OpenID Connect thing, and I was accidentally, and I know it sounds crazy, but if you went and looked at Google's documentation, it's an absolute mess. It's like spaghetti code in documentation. And I was reading the server flow documentation that said that I do not have to validate the signature when I'm using that particular flow, okay? And so that's because of that confusion and the complexity, it leaves open the opportunity for a developer to not check a signature when checking the signature is the absolute most important thing that they can do in that particular relationship. So whenever I'm testing an application that's implementing OpenID Connect and there's an ID token involved, the question I always ask myself when I'm going into this is, what if the developer mistakenly trusted an implicit flow like a server flow? And I know because, and I can do that because I've done it before and I know the implications. So let's go through and demonstrate what that looks like. And this is a dead simple one that I think many of you have probably already seen, okay? But we'll do it just to sort of get things started today. Okay. So we're going to be using Burp Suite Pro, of course. JWT Editor is the extension that we're going to be using to look at the JWTs and analyze them and tamper with them. And then we're going to be testing an application called PwnTub.com. This is actually PwnTub 2.0. The original one is a part of the same suite of applications. This is what I train with. This is what I talk to. This is where I build all my vulnerabilities that I talk about into this suite of applications. So we're going to be testing this, or this is going to be our target app. So I want to exercise the OpenID Connect flow here by clicking the Sign In with Google button. And what you're not going to see, or actually you are going to see it, is just going through the process. And because I've already logged in through, you didn't see the prompt for my username and credentials and to click this button to allow these things, right? I've already done all that off the stage. It's already cached, so the browser just did all the things for me and took me through the flow. And the end result is a created account and now log in. Okay, so I've created the account and simultaneously logged in. And I can go to log out, and then let's look at this process and see what happened. So this here is probably clicking the button or somewhere around in there. But this post to the access token, that is actually coming back from the process. So you see these exchanges happening between accounts.google.com. It would actually be a heck of a lot longer if I had to go through the process of typing in a username and a password. There would have been probably somewhere in the neighborhood of 20 to 30 different requests going back and forth. But all of those are between my browser and Google, so they're not even in scope for what we're doing. The most important piece is this last part for me, where Google now hands things back off to the target application, which is this api.pwnTub.com. And I see this ID token being passed here. Then that results in an access token, which is basically going to be my temporary credential moving forward. That temporary credential gets passed off to users me. It pulls back some user information. You can see there that it's Tim Tomes. And then I can continue to use the application with my access token from that point forward. Okay, but what happens if the signature is missing? What happens if I take this ID token and modify it to have a different, I guess some different claims than what were actually sent by the issuer? So I'm going to right-click this and send it over to Repeater. And we can use JSON Web Token or JSON Token Editor or JWT Editor plugin to do this. And we'll actually just go over to tab mode so we can see some things here. And so I'm going to go in here and I'm going to type in admin.pwnTub.com instead of pwnTub.gmail.com. And we could have enumerated this user or found it in any number of ways. And the application is vulnerable to that. But let's just pretend we've got this piece of information here. And now let's replay this. And we can see we get an access token. Now, we could just have an access token that's invalid, okay? So we don't know at this point in time whether or not it's valid. But let's go and take that user's me endpoint and replay it to it and see what happens. So send this over to Repeater. We'll grab our token here that came from our modification, paste it into our authorization header, and hit send. And you'll see that we're logged in as the administrator. So in this particular case, the server did not check the signature. It did not validate the signature, and the end result of that is me being able to actually log in as the administrator, because what the server did is take that ID token, look at that email, and it said, oh, I've already got an account that's associated with that email. I don't need to create a new one. I'll just log that person in. That's why that signature is really important, because my browser is an untrusted intermediary, and the audience, which is the server, should have verified integrity, and they did not. Now, this is just the beginning. There's tons of signature attacks. So even if they're validating signatures, and if I go over here and I enable signature verification within my application, and we try to do this again, and this is our modified JWT, and I hit send, you'll notice it says expired or invalid ID token. That's because the signature is properly being validated at this point in time. And now I would want to move forward with all those crypto attacks that I said I'm not going to talk about today. Once again, go to that web security stuff from Burp, and it will cover those in great depth. Okay, so that's basically what you would want to do. You want, every time you're dealing with a JWT, absolutely make sure it's checking signatures and that it's doing it properly. That's an absolute must. All right, let's move on to the next use case here, which is JWTs in authorization. Okay, so quite often when you see an application using access tokens, you're dealing with authorization at this point in time. And there's a couple different times you'll see access tokens being used, and you can obviously use it for way more than this, but the vast majority of the time they're going to be used, one, as a part of an OAuth flow, and where OpenID Connect is an authentication mechanism, OAuth is an authorization mechanism. Okay? Now the difference between it here is in the OIDC, the OpenID Connect spec, JWTs are a part of the spec. ID tokens have to be JWTs. Not so with OAuth. OAuth doesn't say that JWTs OAuth doesn't say that access tokens have to be JWTs, but in many cases they are. Just so happens in Google OpenID Connect, they're not. They're just opaque pieces of data, but they can be and quite often are. One of the ways you'll see these used a lot is JWTs uses access tokens a lot is when we're dealing with temporary credentials. Okay, and the thing about temporary credentials, we're talking about sessions. A session is a form of temporary credential, right? You log into an app, you receive a session ID, and the server is now tracking you via that session ID. Access tokens can also be temporary credentials in a stateless application, where I'm using, say, a single-page application on the front end and an API on the back end. When I log in, just like I did here in this app, I'm given an access token, and that becomes my temporary credential. There's got to be something inside that temporary credential that identifies me as me, right? There's got to be something in there, whether it's my email address, whether it's my user ID, that's a direct object of reference to the users table. There's got to be something inside of that access token or that session that tells that server that I am this person. Okay, it's got to identify me. So one of the things I'm looking at, whenever I see an application that's leveraging access tokens as a temporary credential, one of the things I ask myself is, what if the developer used the same claims, right, the same claims in a more accessible token signed with the same key? So I've got an access token, and it may have a claim like sub in it, like here, that's got my user ID associated with it. Okay? What if I can find some other token that the application uses that uses the same exact claim to identify the user ID, but I'm able to make it represent a different user, have a different number in there, a different user ID. So if you've got an application that's using access tokens, look for other places that's using tokens and then substitute them. And this is an attack called JWT substitution. So let's play this out in our application and see how this works. Okay, so I'm going to go in here, and I'm actually going to make this really hard on us, because not only am I going to enable signatures, I'm going to enable encryption. So now we can't even see our tokens. Our tokens are encrypted and they're signed. This is the worst possible case scenario for an attacker. Okay, this is the most difficult type of JSON web token to attack. So let's log in with an existing user here, and the existing user we're going to log in is Cooper. So Cooper at phoneup.com. And it says, hey, you got an email. This is a passwordless authentication system. Anybody use a passwordless authentication system anywhere? Maybe not, maybe. It's kind of like the hotness nowadays. All right, so passwordless system. And I've got the ability to check email here. So I'm going to go to my inbox, and I see Cooper's inbox there. And here's my email that says, hey, here's your code for passwordless authentication. So I'm going to copy that, go back to the app, and put in the code. And I'm authenticated to the app. It's Cooper. That's how those systems work. I'm sure we've done these things before. I've tested them that used emails. I've tested ones that use SMS. They use text message and a phone number. Lots of different ways for passwordless authentication systems to work. Now let's go and let's look at this a little bit more. So it probably started right about here, because that was my log out. So first I sent over cooper.phonetub.com. I get back a 403 that said there's a code required, and here's the code token. Okay. So then I take that code token, and I post it, and I get back an access token. But not only am I sending over the code token, I'm also sending over the value that I typed in that I got through my email. So I got one in an email, put it in there, sent both of these value back across. The server evaluated those two things and sent me back an access token that then I can go and access users.me with and the rest of the server side of the application. Okay? So the interesting thing about this is I've got Cooper in and Cooper out, right? So Cooper goes in here, And then after all this happens, I get Cooper out at the end, right here at the users.me. But there's a handoff that happens in between with the code token. And where am I at here? So I get this code token, and right here, this code token gets handed off for an access token, but Cooper goes in and Cooper goes out. So it stands to reason that if I got the same person in, same person out, and a swap of tokens, that those two tokens have something in them that both identify me as Cooper, right? Something in both of those tokens have to identify the user, which is Cooper in this particular case. Okay? So what if the code token is using the same claim to do so as the access token? That's what we want to try out here. So what I'm going to do is I'm actually going to go in and try to log in as admin. Okay. Now, I don't have the admin's email, right? I'm not the admin. I'm Cooper, so I can't access the admin's email. But what I can do is I can go in here and I can look at the code that came back. And if I assume if that subject is the same person in both tokens, they're using the same claim, then I may be able to use it as the access token to go back and access that same user's me endpoint. So I'm going to go back here, or actually just hit send here, and you can see here this token is no longer valid. So I'm going to take my code token and paste it in here. Remember, this is encrypted and signed. Send it over, and I'm logged in as the administrator. Okay? So I didn't even have to see it. Okay? I didn't have to see it there. I could just assume, based on the behavior, that perhaps this code token is using a similar claim. And if it is, I may be able to confuse the system into treating my code token as an access token, and that's absolutely what this application is vulnerable to. Now let's look at another version of this that I actually find even more interesting. So I'm going to go over here, and I'm going to make this more typical now. So typically, we're going to be dealing with JWSs, signed JSON Web Tokens. So for this next demo, we're using just signed JWS Web Tokens. We're going to be able to see inside them, which is pretty normal when you're dealing with JWTs. Okay, so I disable encryption. Now I'm going to sign up for a new account. So I'm going to go to sign up. I'll use my Gmail account here, my display name, and I'm going to sign in. Okay, it tells me that my activation email was sent. Please check it. I have no idea why it's way over there. That's never happened before, but you get the gist. So I'm going to go over here and check a new inbox. I should have a new inbox, and I do. I've got mine, TJT 1980. Go to the activation. It sent me an activation link. So I'll click the activation link. It takes me back here, and then I could log in to prove that it worked at this point in time, and you would see a load up users.me, and it would be Tim. Okay, so let's go and look at what happened in that process. So I'm going to go down here, and here's the post that I signed up, that I posted to sign up for the account. You see, I got email, I got my email name, avatar signature, and then the API responds back with success equals true, which then triggers the front end to say, hey, check your inbox, we sent you an activation email. So then I check the activation email, I click the link, it loads the application in order to send that token, the activation token from the URL, back to the server again. The server takes that token, and it says, okay, I validated that token. I'm creating the user. Success is true. You've created the user. And then it would go on and provide, I'd be able to log in with it at that point in time to receive an access token for the new user, which is Tim, and continue to move about using the application. Okay. But let's look inside of this activate token. Actually, let's look inside this activate token, and I want to show you something that is very interesting to me. If you look at this, you'll see email tjt1980.com, name Tim, avatar nothing, and signature nothing. What stands out to you about that? It looks exactly like what I sent initially. So if we compare that to my registration request, which was right here, it looks identical. It's the same information. So there is potential here that the server is taking the information that I gave it in the registration request and is just taking it and stuffing it inside the activation token, which is this JWT, and then is reading it back in. I can't modify it because it's signed, right? But it's sending that information over and then receiving it back and creating a user as long as the person proves they are that person by clicking the activation thing, okay? But if these are exactly the same, maybe anything else I send in that initial sign-up request will show up in the JWT. That could be some interesting behavior. So I'm actually going to take this, and I'm going to send it to repeater, and I'm going to add a claim here. Foo bar, hit send, Got success equals true, so I should have a new activation email. Let me go into TJT. There's my new activation email. And if I click on it, the user already exists, so I should get that the user already exists. But let's look at the token that was created as a result of this process. And you see for.bar, which was supposed to be foo, but whatever. I'm a terrible typer. Okay? So that's interesting. I feel like I now have control over arbitrary claims inside of this. And if I can control arbitrary claims, then maybe I can overwrite existing claims. And if I can override existing claims, then perhaps I can override the subject claim to make it anything I want and turn this activation token into an access token. Okay? So let's try that. I'm going to go back to my repeater here. And instead of using for, I'm going to use sub. Instead of using bar, I'm going to use 1. And we'll just guess it's the first one. Okay? Another activation email here. So let's check it. I got that. Pop it open. And let's see what we have. So now I don't see sub 1 at the bottom. Oh, there it is right there. So it overwrote the meaningful claim that I know at this point in time means something to an access token, right? So now I'm going to take this activation token that shows up here. I'm going to go back and replay it again to that users.me to prove or to determine whether or not it'll actually process it based on that claim. So go to repeater, go back to our users me, which is right here. Does this still work? Probably. Nope, it doesn't. Good. That's perfect. So let's go down here, paste that in, hit send, and I'm the administrator. So I was able to forge basically an access token because I controlled the claims through some other mechanism within the application. So this idea of substituting tokens for one another, JWTs, keep an eye out for that. If you see an application that's using JWTs in a couple different places, see how much of those things you can control, start swapping them around and using them in different places, and you might be really surprised what you come up with. Okay? All right, so the last category that I want to talk about is JWTs and information exchanges. Okay, now in reality, everything we've done up to this point in time has been exchanging information in JWTs. Okay, so ID tokens fall into that category, access tokens fall into that category, but these are more things that aren't governed by any types of RFCs. They're not governed by any sort of standard. These are things that developers have made up, things like activation tokens, code tokens, reset tokens, a lot of the things that we've already been tinkering with that you may have seen in applications. We already talked about how tokens are transparent and often contain sensitive information, and in most cases that's not a problem, okay? Because the bearer is often the subject. Like if I am the subject of the token and I can see my own token, what does it matter? Right? Well, and sometimes it doesn't, but sometimes it does. I think we've demonstrated some ways in which it can matter, especially if the app is broken. Okay? But integrity is always the priority when we're talking about JSON Web Tokens. The ability to change that is a huge deal, and that's why normally at a minimum we're going to see JWS implemented here, which enforces signature verification. Right? But sometimes that's not enough. Sometimes the ability to see inside of a token is a problem, and here are some examples here. Number one, stored in local storage for persistence. If you've got a transparent token sitting inside local storage, it's got sensitive information in it, even if it's about me. If I get exploited remotely, or if somebody sits down at my terminal, or if there's a cross-site scripting in that particular application, someone else can steal my token and then look at the contents of it and gain information about me. Sometimes it reveals things about the bearer that they shouldn't know about themselves or others. Okay? And what that means is perhaps the token includes some information about me that then allows me to infer things about someone else. So one example of this that I've seen is a token which had a private claim in it that basically showed an upload folder. And the upload folder had a path in the operating system, but then at the end of the path was an MD5 hash. Well, that MD5 hash was the hash of my user ID. So I just looked at the sub, which was whatever. I hashed it as MD5, and that was my folder. So I knew at that point in time on the operating system exactly where my upload folder was, which means I could also guess that information for every other user of the system. So if I ever found path traversal, I would then know exactly how to get to other people's places within the file store. So things that you could infer about other users would be bad. And sometimes they contain sensitive information about unauthenticated systems, and that's the one that we're going to explore. So what if the developer, another question I'm always going to ask myself if I'm dealing with an application that's leveraging these kinds of tokens, is what if the developer failed to encrypt a sensitive token. So let's take a look at that. Okay, so I'm going to log in with Cooper. Went to the wrong place. Did I need to? Nope, I think we're good. I'm going to log in. I'm going to check my email, go to the inbox. I think I logged in as Cooper. Grab my passwordless authentication token. Paste it in there, and I'm logged in. Okay, so that's the login process. Let's review this process. Again, we've looked at it once before. Let's do it again. So here we are. We're presenting our email. What did we receive back here? We should receive, let me go back to this side by side. We receive a code required 403 with a code token. Then we provide the code token along with the code. It gives us an access token, and then we're able to use the application. Okay, so how do these systems, we're dealing with a stateless system here. And a stateless system means that the server does not remember what our code is. The server, when it issues us that token, it completely says, I have forgotten everything about you. I'll think about you the next time I receive something meaningful from you. It is completely stateless. So everything that the server is going to know next time around when I make contact with it has to be in that request. It doesn't remember anything about the relationship across a series of requests. So that means that this code token has got to have that piece of information in it, right? And if we look at it, you'll see that it's got this subject to, which is Cooper's user ID, and then it's got the code, okay? So it sends the code over to my client, and then when I place the code into the box on the screen, it sends the token that has the code in it and the code from the request, or the code that I typed in the box, gets them both to the server, compares them, and says, okay, they're the same, you're good to go. It verifies the signature to make sure I didn't modify the token to just be what I typed in, right? So it does some of those things, it validates the signature, and we're good to go. And when the developer implements this, or QA is testing it, they look at this and they're like, okay, I see it, that token looks obfuscated to me, we're good to go, okay? So what can I possibly do with this? Well, let's take a look. So I'm going to go in here, I'm going to log in with admin. And now I don't have the admin's email address, right? I mean, I have their address, but I can't go in and check their email and grab the code, but where's that code sitting at? If I go inside and I'll look at the response in this code token, it's sitting right inside the token. So I can just copy this, take it over here, paste it in, and I'm logged in as an administrator. I found this twice in the past year. Twice. And they were on systems that used SMS text messages. And I had the cell phone numbers for the people that I was doing the test for. And so I took the cell phone number, and I could have found the cell phone number even if I didn't have it. I took the cell phone number, plugged it in, okay, got the code, put that in there, and on the other end, the person that I was working with, the developer, he receives the text message, and about 30 seconds later, receives a picture from me of me logged in as him. And immediately I get the text back, and I was just waiting for it. I'm like just sitting there waiting for it, like, we need to talk immediately, right? So we did. And this is a problem I found in 2 different applications over the past year. Just simply because when a developer looks at this, and almost anybody looks at this, they see this right here, and it doesn't jump out at them that there's something sensitive in there that no one else should see. And then even when they do look at it, they're like, well, it's just going to the user that owns it, right? Not thinking about the way that this system works. And it can lead to flaws like this. Okay? So these are 3 of my favorite vulnerabilities. I love finding these things. Love it when I see an application using JSON Web Tokens, because these are things that people just don't think about. Okay? Well, how much time do I have? I got 20 minutes? Awesome. Then I'm not going to conclude yet. Okay? Let's actually jump to a section I didn't think I was going to have time to talk about. Yes? Sure. I wouldn't be able to tell you anyway.
The sites or applications they were using, did they write this module themselves?
Yeah, those are homegrown apps.
So they weren't downloading a framework?
No, they built it themselves. Yeah. And frameworks don't do this for you anyway, right? Using JWTs are things that you're mostly going to be developing yourself. I guess there may be packaged solutions that employ JWTs, right? Like almost kind of following Google's guidelines of how to do OpenID Connect with them. And there's probably a library involved in that as well. So yeah, that's possible. But in most cases, when you're seeing these types of systems, a lot of times they're homegrown. Yeah.
wondering if like, it's possible that like, they potentially were using a framework that was missing.
Because both apps were vulnerable to it? Well, here's the interesting thing. The one developer, there was a developer from the one app, the company that wrote the one app, that was working at the company of the new app. So potentially could have been the same guy, same mindset in it, okay? Because these were two, they were kind of quasi-partners, but the development teams were separate, and one guy did make the jump at one point in time. I'm not going to throw him under the bus. I've made these mistakes too. But as soon as I showed him what happens, he's like, oh my gosh, I know exactly what I forgot to do. I got to encrypt the token. Of course, you go and encrypt the token, you're good to go. Okay. So I do have a few extra minutes, so let's talk a little bit about that encryption piece, because this is actually kind of fun. So when we were talking about missing signatures, okay? And then if the signatures miss, even if the signature's not missing, you should definitely check to make sure the signatures are being tested properly, okay? So missing signature verification is just the beginning. It's just the beginning. Once again, there's a link to the RFC if you want to check it out. But reading through it, there were 4 things that stood out to me, 4 points. Number 1 is the implicit wording all the way throughout the RFC tells you that the Jose header parameters, okay, which is the thing that's responsible, and actually this, the next bullet says this, the Jose header parameters are user controllable. The Jose header parameters are also the ones that describe the cryptographic operations and all the inputs into the cryptographic operations. So that tells you right away the user controls the cryptography and the inputs to how that cryptography is applied. That immediately is kind of like, well, that sounds like a really bad idea. Okay. Well, here's the third thing, because even if a developer reads that and says, okay, that may be what the spec says, but that's not what I'm going to do. Sorry, you can't do that, because the the specification requires all implementations to process the Jose header. They have to understand and process it as the user provides it. Any variation from that now makes you RFC non-compliant. Okay. And then the last piece, the last kind of icing on the cake here, is they must be processed in the manner defined by the specification, using all of the old and dated algorithms and stuff that it talks about, okay? So all 4 of these pieces together end up creating a really bad situation, almost kind of like a perfect storm for cryptography with regards to JWTs, okay? So signatures, libraries that are total RFC compliant, the signatures that they create can be exploited by a myriad of different things that started way back in 2015 and is still going today, as I mentioned, a couple different things that were released at Black Hat. There's one called the none algorithm. If you've never heard of the none algorithm, the spec usually actually says, just put in the algorithm none and we won't calculate a signature. That's controlled by the user. So if the library is spec compliant, you can forge tokens all day long. Self-signing using a JSON web key. So there's something in the specification that says, hey, we'll sign it, and you can actually provide the key that will sign it, that will check the signature for. So you sign it with your own key, give it the key, and it'll use the key you gave it to check the signature. Awesome, right? So you could use that to completely bypass signature verification and forge tokens. Then there's some odd confusion between how RSA works. So like the Google OpenID Connect, they use a publicly, they take their public cert and they put it out on the internet, and the way that this whole system works is you go out you will provide a signed token that was signed with their public key, and then you go out and pull down the public key, obviously, sign the token, pass it in, they'll validate the signature with the private key. But there was a confusion issue in the spec where you could actually go down and pull their public key down like you would, sign the token, but then instead of passing it in, telling it it's RSA, you pass it in and tell it it's just using HS256 or 512 or whatever, an HMAC basically, a symmetric, and it would actually then just use the public key on its end to check the signature. So you basically just create this almost similar to the self-signing, but you're using their public cert to sign it and then telling them to use their public cert to check it. Okay, so there was a confusion there. And then tons of other crypto stuff, because crypto has not aged well for JWT since that spec was created back in 2015. Okay, and the rub here is that fixing any of these things causes your implementation of it to be non-compliant with the specification, which is supposed to be one of the things that we like about JWTs, that they are a specification that we want to comply with. Okay, so what happens is you have developers that are using libraries that, in most cases nowadays, when typically if you're going to be implementing JWTs or you're testing an app that implements JWTs, they're using a library that's no longer spec compliant, because that's the way they've been fixed. They've gone and been fixed. I hardly ever see these vulnerabilities anymore, simply because The libraries are on top of it. They fix their stuff, but now their libraries are no longer spec compliant. So regardless, when I'm testing an app, if they're using JWTs, I make that assumption in my head and just say, what if the developer is using a library that's 100% total spec compliant and makes all these things available to me? Well, when it is, I'm going to check for those. And actually, Burp makes it pretty easy to do so. I don't know if any of you ever messed with this before, but JWT Editor actually provides these attacks. And so if I go back and look at our ID token here, and we should be, at this point in time, signing things, right? Yeah, so it's not working, and I still have the admin email address in here. There's this little attack button, and that allows you to conduct the embedded attack, the non-signature attack, the key confusion attack, signing it with an empty key, something called psychic signature, which is one of those, it's too complex for me. I'm not real smart when it comes to crypto stuff, so I don't get into the deep stuff, and that's beyond my understanding. And then the ability to embed collaborator tokens, which is really odd too, because there's this other thing inside the specification that allows you to provide a URL for where the key is. Does anybody remember, what was the old school PHP vulnerability? Where you could, the include. There's like a local include, and then there's, you guys know what I'm talking about? The file include, LFI and RFA, remote file include. It's basically remote file include vulnerabilities for JWTs. You just say, hey, go to this URL and pull down the key that I put there, and then check that for signing. But the cool thing about that is now the server is visiting that URL, which becomes what vulnerability? Server-side request forgery. Yeah, so you can use, and then there's another one, which is called, there's a KID claim, which is supposed to be an ID for a key, and if the server is storing keys in a database or in a file or something, the key ID is what tells the server, go look up the key based on this ID. Well, if it's on a file, then you're looking at path traversal. If it's on a database, you're looking at SQL injection. Depending on where, if it's in an XML file, you're looking at XXE. So you've got tons of injection vulnerabilities possible. And this is only if the library that they're using is actually compliant with the specification. All these things become available to you. But there's just so many cool things that you can do with JWTs that we could sit here and do demos forever, okay? But just know that Burp does give you the ability to automate some of these attacks here, and Burp does, or Portswayer does a really good job of walking you through these within their Web Security Academy, so I highly encourage you to go check that out. It's really good stuff, okay? So now I think I'll conclude. Sounds like a good time to do it, right? All right, so the JWT specification allows for a whole lot of pitfalls, right? I did get a chance to mention a lot more attack vectors than I anticipated doing, but there's even more beyond that. There's a great quote by, I think Tai Duong is his name, not even really sure, but if crypto standards give users enough ropes, they're going to hang themselves, and JWT gives you a bunch of ropes, like a whole bag of ropes, right? You got a whole bag of ropes to hang yourself with. A lot of damage can be done with a tool that isn't fully understood, right? And I think that's demonstrated best by the substitution vulnerabilities and stuff that we talked about in here. It's like, I'm going to tell you, this drill looks like a great toothbrush. It just doesn't work out very well for you. It makes a mess. So there's that, and then just understanding that they're a core component. They're not going anywhere. So if you're not fully, if you're in the testing field or you're a developer and you're writing code, make sure you understand these things and how they can cause trouble both for you as a developer and how they can lead to really nice, really good fun times if you're a tester, okay? So there's some resources, PwnHub, the application we've been testing. It's a whole suite of applications. If you've never been in any of my classes, it's the target we use. Definitely check that out. There's some good links here to some, as I did some research on JWT, those were good resources that I think are worth checking out and reading through. And this one's actually, the bottom one's actually a pretty good, if you're a tester, it's a neat kind of playbook on JWTs there. These are some credits and attribution for some of the pictures that I used. And this is just some information about me. Subscribe to my mailing list if you want to get information about blog posts I write or classes I teach. But I teach classes on web application penetration testing. It's the only thing I do. I don't try to be a jack of all trades. I do one thing, and I do one thing. I'm a one-trick pony, but I'm good at my trick. All right, that's what I tell my clients. They're like, hey, will you do this net pen test? I'm like, no, I won't, because I only do one thing. I do it good, but I only do one thing. All right, so I train on web app pen testing. I do web app pen testing if that's a service that you are interested in. I also do development stuff. Okay, so if you've got, particularly in the area of security, if you need help remediating vulnerabilities that you don't fully understand, I partner with a lot of organizations to do that as well. And then I got a whole bunch of garbage up on landmaster53.com, old blog posts I've been doing since like mid-2000s when I was doing red team stuff. So are there any questions for me? Yes. You can feel free to hit the button on the mic, and that'll actually light the mic up and give you the ability to use it.
This is actually just quick. Can you go back to the JWT signature problem slide?
Yeah, right there.
I just wanted to see it again. Thank you.
Yep, okay.
How are JWTs different from cookies in regards to both of them behaving like access tokens?
Yeah, so very different purposes, right? Those are two different ways to manage credentials, okay? So the JWT is the credential, and the session ID is also a credential. Where cookies come into play is how they're managed. So cookies allow you to, or they introduce the idea of implicit credential management. So when you have that temporary credential set as a cookie, you know the browser is always going to send it back. It doesn't require any client-side code or user interaction to send that cookie back. When you're using explicit temporary credentials, which again, you can use a token as a cookie, you can use a session ID as a cookie. You don't, where that goes doesn't matter, okay? But if you're storing a session ID or you're storing a token and you're doing it explicitly, you're having to store it somewhere on the client. And the client-side code is responsible for then taking that data and sending it back with every single request. So it's explicit in that it doesn't just automatically happen. And there are, I could give another 15, 20-minute talk on the benefit, the advantages and disadvantages of both of those. And that's something we dig pretty deeply into in my PWAPT class, Practical Web App Pen Testing. Any other questions? Yes?
Does that allow for replay attacks to be a little bit easier when they're fully stored on the client?
Which one? You talking about? I mean, either one of them are vulnerable to replay attack, right? Because a cookie can be captured off the wire just as easily as a token can be. So both of them could be replayed. The downside to a stateless token, truly stateless, because I've seen developers introduce state into a token, which actually defeats the purpose of using a stateless token. So that can happen. But if you throw that out, some of the disadvantages of using a token as a stateless temporary credential is there's no way to log it out. Right? You have to use something like a timestamp that's stored within the claim. And if you saw the EXP claim, as we were looking at JWTs, that tells the JWT library, hey, this is the timestamp when it should expire. That's really the only way to log a token out. Other than that, with a session, an actual active stateful session, the server can just say, I'm ready to throw this thing away right now, and it can delete it. And any request that comes in, it'll just say, sorry, I don't obey that thing anymore. But with a token, it doesn't remember anything about anyone. It just receives it and says, is this thing still valid? It is. I'll process it. There's no way to log it out. Yeah. Yes?
What is your biggest challenge in analyzing web applications?
Say again?
What is your biggest challenge in analyzing web applications?
Web applications in general? Biggest challenge? Probably understanding the variety of standards and protocols that go into it. There is a tremendous amount of things to know about web apps. The developing community is moving so quickly from one library to the next, from one technology to the next, from one design pattern to the next. I mean, in the past 20 years, we've had 4 different architectural design pattern shifts in how we create web applications. And all of them introduce different vulnerabilities and different behaviors that if you're not writing web apps, it's very difficult to be an adequate security tester to test web apps. It's just critical to understand all the different things that the developer has to do and how they think about the problem. Who asked the first 2 questions, by the way? I think she already beat Street. She left. Who asked the second one? You did? Okay, and then the third one was right there in the orange. Cool. I got these for you. They're lockpick kits. Awesome. Any other questions? Yes, sir. Yeah, so you're talking about like macaroons and pesetos. So I have no idea what goes into introducing a new standard or how it gets ratified by IETF or how all that works. So I don't know why it hasn't. Honestly, I don't. Because I mean, Google created macaroons, right? So you would think that Google would have some leverage there, but how that body works, I have no idea. None at all. If anybody else has any input on that, feel free to share, but I'm clueless in that area. Okay. Any other questions? All right, I hope everybody enjoyed it. I hope you took away something useful. Have a great rest of the day. Enjoy the conference.
Let's hear it for Tim Tomes.